Today I am going to calculate the friction factor using Colebrook equation by Excel. Now you know that Colebrook equation is a nonlinear equation, so that equation is given here, and along with other data that like diameter, roughness factor, roughness height, fluid density, dynamic viscosity and fluid velocity is given here. Now as the Colebrook equation is a nonlinear equation, so if you see here, so this is a nonlinear equation, and here the other parameter epsilon d Reynolds number is given. So f can be found by root finding method. So here I am using Newton-Raphson method. So by using Newton-Raphson method, f can be found out. Now here is the Newton-Raphson method. So f of n is equal to f of n plus 1 is equal to fn minus f of capital F of f of n f dash fn. So that f of fn is the functional value, so that functional value is written here. So f of f is, from this Colebrook equation we got the functional form 1 by root f plus 2 log epsilon by d 1 by 3.7 plus 2.51 Reynolds number to the power f. Now here the derivative we can easily calculate by central difference scheme. So f dash f is equal to capital F f plus h minus f m minus h by 2h. So here h is very small number. Now here I am putting all this the parametric value, so diameter, epsilon, density, viscosity, velocity. So from that I am calculating Reynolds number. So you can see here Reynolds number is rho dv by mu. Okay, so we are getting that. So that is nearly 1 lakh, and h is 0.1. So now from first iteration, so old depth, this is the gauge value. So I can put as this. So this is the gauge value, and then first we are calculating that functional value. So at f is equal to 0.2, what will be the function value? Then we are calculating f plus h. So so that is the formula. So here we are calculating f plus h. So we are getting the value. So f of h minus h. So here this is the minus h. So we are getting the value, and then we are calculating the derivative. So derivative, so that is minus 177.96, and then we are calculating by using Newton-Raphson method. We are calculating the f. So this is the Newton-Raphson method. We are getting the f. Now so that f will be the next iteration gauge value. So here, okay, so we are just copying that value, and then again we are calculating the functional value f plus h, this everything, and again we are getting this. Now if again, so this will be the next gauge value. So we are putting here, and if we do the calculation, if we see after fourth iteration that functional value is e to the power minus 6. So we can stop the iteration, or we can go another iteration. So if you see, if you go another iteration, so same thing. So this value will copied, and then if you see that functional value is very small, okay, and everything is very small, and after doing all this calculation we'll get that it is nearly same. So the root of the equation or friction factor is 0.044. Now we got that. Now here if you see here, this function value I am taking as a log 10. So this is, now here I am taking gauge value is 0.01, and this function value I am changing here. So I am taking log natural. So earlier calculation I am took that log 10. So now here this is log natural. If I take log natural, so my f of f value will be this, and f of f plus h will be this, and f of f minus h. So I am taking log natural. So df will be this, and f for that after doing Newton-Raphson method, so friction factor will be 0.008. Now if I do like that, so now here the friction factor is something 0.00844. So if you take log 10, that friction factor will be different. If you take log natural, friction factor will be 0.00844. Generally in Colebrook equation, that friction factor is 0.00844.